Hi everyone, this video is part 2 of model building. So let's get started. The skills we will cover in today's lecture are as follows. First of all, we will learn about random forests, and then we will see how they work, and in the last we will see how to evaluate random forests. So let's move forward. What is actually a random forest in R? In our programming, random forest approach is supervised nonlinear classification and regression algorithm. It is a symbol of decision trees known as forest to get more accurate predictions while providing flexibility. Each observation is fed into every decision tree. The most common outcome for each observation is used as the final output. A new observation is fed into all the trees and taking a majority vote for each classification model. They are called random because they choose predictors randomly at a time of training. An error estimate of cases is made for the cases which were not used while building the tree. That is called a double OB, which means out of bag error estimate, which is mentioned as a percentage. So let's see the advantages of random forests. Random forests are much more efficient for large datasets to handle. The learning is fast and they produces higher accuracy on prediction, which is a good point. They maintains accuracy even if the data is missing. Overfitting is not a problem in this algorithm. Efficient use of all predictive feature as it can handle plenty of variables at once. So now let's see the disadvantages of random forests. The first one is that random forest requires different number of levels for much accurate prediction of the training model. It requires a lot of memory or parallelized memory while training a large set of trees. Then we have another disadvantage, which is that in order to produce the best output, it takes more computational time and resources, as random forest is a combination of trees. So now it's time to learn that how random forest actually works. Random forest takes random samples from the observations and random initial variables and tries to build a model. The working is as follows. First of all, it randomly chooses n samples from the training data. Then it grows decision tree from sample, and at each node of tree, it randomly selects d features. Then it splits the nodes using features that provide best split. Then it repeats the steps 1 to step 2 until the number of trees you want to create using subset of samples. In the last, it aggregates the prediction by each tree for a new data point to assign the class label by majority vote. So you have seen how they actually works. Now, let's see how to use a random forest in your RStudio. The package random forest in R programming is used to create random forest. Use the below command in R console to install the package. You also have to install the dependent packages if any. So let's see. Just use the install.packages keyword and pass the name of the random forest in strings. Now let's see the syntax of random forest. The basic syntax for creating and analyzing random forest in our programming language is below. Just use the random forest keyword and pass the parameters of formula and dataset, where formula represents a formula describing the predictor and response variables that represents a model to be fitted. Then we have dataset that represents the name of the dataset to use that contains the variables in that model. Now it's time to do some practice. Let's move to RStudio. Well, first of all, I will create a variable with the name of ADV data frame. And here I will say read.csv, and I will pass the URL for reading the CSV file. And down here I will say head ADV data frame. All right. I want to predict if the purchase value is yes or no. 0 represents no and 1 represents yes. I will first of all have to say install.packages, and then I have to say random forest. And then you can just run this line of code, but I have already installed this package. So let's move forward. I will load the library of Part2, and then I will load the library of random forest. All right. And here I will say RF model, random forest model. And inside this model, I will use the function of random forest. All right. And what I want to do is to predict the variable of purchased. But before using this variable, I have to convert it into factors. So I will say ADV data frame and take the column of purchased and make factor, and I will say ADV data frame and take the variable of purchase and levels equals to C and 0, 1. All right, now I can use this purchased column. I want to make a prediction of this column, and what variables I want to use for prediction is age and estimated salary. And let's say I also use user.id. And here I pass the data equals to ADV data frame. And here in this line, I say print RF model. And in the last line, I say print importance. I say take RF model and type equals to 2. Now let's run it. You can see in the console that the number of trees is 500 and the number of variables tried at each split is 1. Here you can see a confusion matrix that tells that the correctly predicted class of 0 is 233 and 15 were wrong. And for the 1, the correctly predicted classes were 128 and wrong were 24. The class error is 0.09 for 0 and 0.1 for purchase of 1. And here you can see mean decrease skinny, and the age column has the highest importance for predicting the purchased value. Now let's move forward. Now this time I will do something different, but first of all, let's do something with our data frame. I will say head ADV data frame. Let's remove this gender column from our data frame because feature encoding is not a part of this course. Let's create a new data frame with the name of ADV data frame 2. And I say subset. And by using this function, first of all, I will provide the original data frame. And then I will use the select function. Here I say -c, minus combined function, and I pass the name of the column that I want to remove. Let's name it ADV df2. All right. Let's say head ADV df2. Now it's pretty good. You can see these 4 columns inside your data frame. All right. Now, what I'm going to do here is that I'm going to split the dataset into training and testing part. So before doing that, I will have to first of all install a package with the name of ca2. Let's do it. The package is being downloaded. All right. Let's load the package, library, CA tools. That's great. So now I will say split, and inside this variable, I will say sample dot split, and I pass the data frame advdf2, and I say split ratio equals to 0.7. This means that 70% of my dataset will have the training part on the new rainforest model, and the 30% of the dataset will go into the testing part. So I will say train equals to subset. All right. And here I'll pass the data frame advdf2, and I'll say split equals to true. All right. And similarly, I will say test, and I will say subset advdf2 and split equals to false. Well, I had to put it inside the quotes, and it should be written in this way. Now I will set the seed for random forest. I will say set.seed120, and here I will say random forest model 2, and inside this model I will use the random forest function. I will say x equals to, which stands for independent variable. I will say take the training part and take every variable except the last one, which is purchase, and I will say y equals to test and take only the purchased column from the test set, and then I say entry equals to 500. The number of trees in this random forest should be 500, and now I say RF model 2, and down below I say warp rate equals 2, because I'm going to do the prediction. I say predict, and I'm going to predict on the test data. First of all, I will pass my rainforest model 2, and then I will pass the test set, and I will say take every column except the last one, and it should be in the parameter of new data. And here I will create the confusion matrix. I will say table, and here I will say test, and I will say take the fifth column and wirepred do a prediction on this column, and in the last I will say variable importance plot and make the importance plot for rainforest model 2. All right. You can see a confusion matrix for your rainforest here, that the value for the purchased of 0 that represents no has 107 correct predictions and 41 wrong predictions. But for the purchase of 1 that represents that yes, the customer has purchased, has correct predictions of 25 and wrong predictions of 27. And that shows a high estimate of error rate. Let's remove this line and run it more important plot. So you can see here the importance of these independent variables. You can see that the age has the highest importance. Well, now let's take an example of regression. So I will load the library of maths, all right? And here I will load the dataset of Boston. Now, what I want to do is to make a prediction for this MADV variable. So first of all, I will set the seed and set the seed 18. And now let's just split the Boston dataset into training and testing set. So first of all, I will say Boston index equals to sample 1 to row, n row, Boston, n row, Boston divided by 2. So that is how I have split my dataset, I will say Boston train, and here I will say Boston dataset, and go inside this dataset and take the Boston index, comma, and similarly I will say Boston test, and here I will say Boston, and I'll say minus Boston index because I'm going to subset it. And then I create another rainforest model. Let's name it rainforest model 3. And I say rainforest function and predict the MEDV and take all of the independent variables from this dataset, and I will pass some parameters such as data equals to Boston train. All right, and importance equals to true, and MTRY equals to 4, and number of trees should be 500. And here I say importance rainforest model 3, and I say type equals to 1. And next I say widespread equals 2. And here I will do the prediction. I will say predict, take the RF model 3, and the new data is equals to Boston test. All right. And here I will paste some function for the plot. As you can see, I have used the plot function. I have posted the Y prediction and what to predict. Then I have provided the labels and title of the plot and colors, etc. In the last, I will copy some code, which is a function to calculate the root mean square error for this model. And I will say score, and I will use the RMSE function, and I will pass the workread here, and I will say Boston test and MEDV, and here I print the score. Now let's run it. Well, at first you can see the importance of these columns, and here you can see the plot, which shows the predicted versus actual value, and this is the fit line. Now you can see that some of the predictions are dispersed in the plot. The dots close to these lines are actually the correct predictions. And here you can see the root mean square error for your rainforest, which is 11.84. And that is how you can use a rainforest for both regression and classification. Now let's get back to slides. So here's what you have learned today about rainforest, its advantages and disadvantages, their working, and how you can do their evaluation. So this is the homework. Clean the dataset, build a rainforest, and do some evaluation. Now good luck, see you next time.